as a part 2 of the previous video. In the part 2, we saw in how many ways reducing latency is going to benefit the ADAS. Now in this video, we are going to see how AI chips, artificial intelligence chips, 5G and edge computing, they are playing a transformating role in minimizing the delays or minimizing latency across the ADAS functionalities. Right from sensor data processing to real-time decision making, below is the detailed breakdown of how each technology contributes to the latency reduction and robustness. Okay, so in the previous video which we saw how latency reduction is enhancing the functionality of ADAS. Now he will see what are the various technologies which are enabling the latency reduction and the robustness in the ADAS perspective. First is when it comes to AI chips, specialized hardware for ADAS. These AI chips manufactured by NVIDIA Drive, Tesla FSD, Qualcomm Snapdragon, Mobileye IQ are designed to accelerate neural network computations, enabling faster perception and prediction and control. Okay, so this is to accelerate. This word is very important. These are designed to accelerate the neural network computations. Okay, and this is enabling faster perception, prediction and control. Now how AI chips reduce the latency? The most important technique is parallel processing and hardware acceleration. Now traditional CPUs processes tasks sequentially, while AI chips use parallel computing to handle multiple operations simultaneously. Alright, these AI chips, which includes the graphical processor unit, telematics processor units, ASICs, all these use parallel computing to handle multiple operations simultaneously. Alright, for example, a Tesla full self-driving chip, which is acronymed as FSD, it processes 2000 frames per second, drastically reducing perception latency. So a traditional CPU can only process 100 frames per second, but a FSD chip by Tesla can process 2300 frames. Now do you understand in how many ways, or by how many times, how many multifold times a AI chip is able to process faster than a traditional CPU? Now when it comes to on-device AI interface, AI chips perform real-time interface on vehicles electronic control unit, avoiding cloud dependency. Okay, example, Mobileye IQ processes camera, radar and lidar data locally. Okay, and when it comes to reducing decision making delays, it is reducing decision making delays to less than 50 milliseconds. Previously the limit was 100 milliseconds. Now because of these AI chips, it is further reducing the latency to 50 milliseconds, and this is being enabled by Mobileye IQ processor. Now coming to optimized neural network, the AI chips support quantized, pruned, sparsity aware models, reducing computation time without sacrificing accuracy. Now coming to NVIDIA's deep learning accelerator, it enables low latency object detection using optimized CNNs. Okay, NVIDIA's deep learning accelerator, it enables low latency object detection using optimized CNNs. Now what is the impact on ADAS? When it comes to impact on ADAS, faster obstacle detection, real-time path planning and lower power consumption. Now this is something, in case you are thinking this is reputation, trust me, all these advantages are enabled by these modern technologies, enabled by the AI chips. To proceed further, how this 5G connectivity is also enabling the ultra low latency. Now 5G networks provide 10 milliseconds latency. See, already you are seeing from 100 to 50, now it has come to 10 milliseconds. Now its latency is enabling near instantaneous vehicle to everything communication. Okay, now 5G reduces latency in ADAS, and it enables faster V2X communication. Vehicle to vehicle, cars share speed, braking and hazard data in real time with a delay of 5 milliseconds. Alright, so vehicle to infrastructure, traffic lights, road sensors, the smart cities relay congestion accident alerts instantly. For example, a car relays 5G V2X alert about a sudden brake 200 meter ahead, allowing AEB to preemptively engage. Okay, preemptive is nothing but a more glossy word for proactively. Okay, in case you think this preemptively is a too high-fi word, just replace it by proactively and reread this sentence. You will clearly understand. Now, when it comes to high bandwidth sensor data sharing, 5G enables raw sensor share between vehicles, improving collective perception. And for example, a truck blind spot camera feed is streamed to nearby cars via 5G, reducing occlusion related risks. So because of the faster 5G connectivity, it can stream in a more faster, thereby informing the nearby camera about the truck's blind spot. Now, when it comes to cloud edge synergy, 5G enables split computing where some tasks run on the vehicle while others offload to cloud compute. Again, here there is a bit of technology involved. There is a algorithm which tells the CPU which task should be run on the vehicle with low latency and which can be offloaded to the cloud. Okay, for example, HD map updates are fetched in millions via 5G, keeping navigation systems current. Okay, so navigation systems will take its own time, and HD map updates are fetched in milliseconds via 5G. So what is the impact? Impact on ADAS is collision avoidance with the help of near instant hazard warning, improved traffic flow enabling adaptive cruise control, and enhanced fleet learning OTA updates for AI models. So these are the positive impacts on ADAS. To proceed further, edge computing. The third technology which we are going to discuss is edge computing. Edge computing is also known as decentralized processing. Edge computing moves computation closer to data source, reducing reliance on distant cloud servers. And how edge computing reduces latency in ADAS. And A, localized data processing. Instead of sending all data to cloud server, edge nodes process data within 10 to 20 milliseconds. Okay, for example, a smart traffic camera processes pedestrian detection locally and sends only alerts to the nearby cars. Now, you understand this? A smart traffic, it processes pedestrian detection locally and selects only to the nearby car. Now, this requires a bit of thinking or artificial intelligence, because there is no point sending information about pedestrian to some car which is some 1 kilometer away. So it has to have a proper definition about the nearby car, and it has to ensure the information goes to the only to the nearby cars. Now coming to the distributed AI interference, edge AI servers run lightweight models for traffic sign recognition, pedestrian trafficking, reducing vehicle compute. And example, NVIDIA Metropolis uses edge AI to analyze traffic cameras and send real-time alerts to connected vehicles. Okay, so how does it further help? It helps by reducing the network congestion. By processing data at the edge, bandwidth usage drops, preventing delays from network overload. Example, in a smart city, edge nodes aggregate traffic data, sending only critical updates to vehicles. Alright, now coming to the impact on ADAS, faster response to dynamic road conditions. It has lower bandwidth costs, no need for constant cloud uploads, and also improved scalability. It supports thousands of connected vehicles. Okay, so naturally, edge computing is enhancing the scalability and enhancing the number of vehicles it can support with the help of edge computing. Now, again, as as advantageous as individual technologies are, now we will see how the combination of these three technologies is going to enhance the ADAS ecosystem. Now coming to the AI chips, it processes sensor data in less than 50 milliseconds on the vehicle. And coming to the 5G, it enables 10 milliseconds V2X communication for real-time hazard alerts. And edge computing, it offloads heavy AI tasks to nearby servers, reducing cloud dependency. Alright, so these three, how are they going to overlap, or how are they going to give their combined benefits? For example, we'll take the example of the emergency braking. which has all these three technologies combined. When it comes to obstacle detection, in traditional ADAS, it has a camera which is dealing with the CPU, has latency of 100 milliseconds. But when it comes to the synergy of these three, the synergy of AI plus 5G plus edge, camera is having a latency of less than 10 milliseconds. When it comes to V2X alert, with the help of 4G, it is having a latency of 50 milliseconds, and with the help of the synergy, it is having a latency of 5 milliseconds. On cloud processing, cloud server is 200 milliseconds, and with the help of edge server, it is only 20 milliseconds. So you can understand the latency has come down by 10 times. It has reduced by almost 90%. Okay, now here you can see from total reaction time 350 milliseconds has come down to 35 milliseconds. All right, and when it comes to outcome, how does this affect the outcome? Late braking enables a collision risk, and early braking, it can enhance the avoidance. It ensures the avoidance for that matter. All right. So the conclusion is integration of AI chips, 5G and edge computing will revolutionize ADAS by slashing the latency by almost from 100 milliseconds to hundreds of milliseconds to less than 50 milliseconds. Okay, actually I already showed you some applications where it is even going below 10 milliseconds. It is further enabling the real-time V2X communication for proactive safety and also reducing cloud dependency via edge eye processing. So this triad of technologies, this triangle of technologies ensures the future of ADAS and autonomous vehicles will be safer, more responsive and more reliable, paving the way for fully autonomous vehicle. Now all these technologies, as much as they are helping the ADAS functionalities, the main goal is to make the vehicle fully autonomous. That is the main vision for which all these technologies are being developed. So what are the mitigation strategies for safe zonal ADAS and also to maintain ISO 262 compliance? Okay, we will see how it is affecting the functional safety. All right, now coming to the functional safety perspective, the hardware level safety, when it comes to hardware level safety, lockstep course, power communication redundancy, hardware positioning, all these are very important, where you have to implement dual triple redundancy, dual power rails, and also isolate ASIL-D functions via memory protection. And when it comes to software level safety, hypervisor based isolation, QNX to separate ASIL-D QM functions, and time triggered architectures for deterministic ADAS responses, and watchdog timers for heartbeat monitoring to detect the crashes. All right, now when it comes to network level safety, the time sensitive networking for low latency deterministic communication, and security gateway firewalls to prevent cyber intrusions into ADAS zone. This is something which I already touched upon. Now coming to the functional safety certification, this ASIL decomposition, split high ASIL functions across the zones, and fuel injection, fault injection testing to validate operation behavior. These are all the various mitigation strategies for safe zonal ADAS architecture. Okay, so as definitely zonal architecture has advantages, but even then we need to implement some mitigation strategies so that it is meeting the ISO 26262 compliance. Okay, the point is, just because you are implementing zonal architecture, it does not mean we can overlook the ISO 26262 compliance. Now when it comes to real world example, Tesla's zonal transition based on the legacy model SX, it is domain based separate ADAS ECU. Okay, but now when it comes to Cybertruck, it has implemented zonal, which comprises of the FSD computer and also zone computers. I already told you the acronym of FSD. Now when it comes to the pros, it has definitely faster updates and better redundancy, but there is a particular con. This is something which is not expected, but definitely there is a con. If FSD computer fails, all the auto features fail. So this definitely requires a backup. So in conclusion, we will see the factor, domain architecture and zonal architecture. So this leads to failure isolation like high dedicated ECUs, lower shared compute. Okay, in domain architecture, it is very high because it has dedicated ECUs, and in zonal architecture it is low because of the shared compute. And when it comes to redundancy, it is limited, but it is better because of zonal backup. When it comes to complexity, it is high because of many ECUs and it is lower because of centralized ECUs. When it comes to safety certification, easier per ECU, ASIL, harder mixed criticality, and cyber security risk, lower, higher Ethernet based. All right, in domain architecture, it is lower because it is CAN based, and when it comes to zonal architecture, it is higher because it is Ethernet based. So what are the key takeaways? The key takeaways are zonal architecture improves redundancy and simplifies wiring, but introduces single point failure risk. So one way it is reducing the cyber risk, but in another way it is increasing the cyber risk. So the mixed criticality systems require hypervisors, lockstep cores and TSN for safety. And coming to OEMs, the OEMs must balance performance gains with rigorous ISO 266 compliance in zonal designs. So this particular trade-off, this must be designed by the OEMs. And the shift to the zonal architecture is inevitable for scalability, but functional safety must be re-engineered to prevent the new risks. Okay, so if everybody has decided that zonal architecture is the future, this is inevitable for scalability, but functional safety must be re-engineered to prevent new risks. The functional safety must be rethought about, redesigned to prevent new risks. And the future vehicles will rely on AI driven safety monitors, self-healing networks to mitigate those challenges. Okay, so as on now, there are some external patches which will heal the network, but in the future the self-healing network is the future which can heal the network by itself and thereby mitigate these challenges. Thank you for listening.